Hello guys, in the previous class we have just discussed about the remaining things, especially in the isothermal, the pressure difference, the thermal pressure difference, if the temperature changes, how it will be, and a little bit of other thing also we just saw, and a little bit of Pascal law we also done. So Pascal law is so simple: static should be, acceleration should be zero, and what is the other one kind of thing? All the pressure stings to a point. Okay, these are the three most common basic things for the Pascal law. So next one is you would have seen about this one. So this one is the far most important thing. Okay, so in this the pressure, it means the force we applying over the first point is so much lesser, but here we are getting so much higher amount of pressure force, so much higher we used to get in this side. I think so we can understand this one. Let's go to the next one. Now we can see here this is a manometer. So for example I'll just show to you, so you can see this is a manometer. So in this the fluid is being placed here, because let us assume this is a mercury or something or other fluid. So this is kind of manometer. So here you can see whenever you see the free surface, here the free surface, here the free surface, here and here the pressure will be so much equal. So when you just go down to it, but it should be in equal length, since the fluid is a fluid that is being placed inside is all the fluid is same, so that's why the pressure 1 and pressure 2 is equal. So while you are just going to the problem, you will have a clear cut understanding. So next case you can see about this one. You can see in this the area is so much lesser, in this the area is so much higher. When you apply it means F2, it means force over here. Here the flow will also gets multiplied due to the increase in the area. So you can see here as the A1 is so much higher, here it is so much lesser. So the F1 is also getting so much higher, here the F2 will be so much higher. So okay, for that only when we apply little amount of force here, we will get huge amount of force in this side. So as I just told about in yesterday class about the hydraulic jack. So you can see here in hydraulic jack what they will do, here the little amount of force is applied. It means this F2 you just consider here, this F1 you just consider this side. This side it means you place a plate over here. So I think so you are getting and catching the point so much quickly. So okay, this is a smaller thing type of thing, that has been okay. So next thing, it has been it means this entire thing is based upon conservation of energy. Conservation of energy. Just take down this conservation of energy. Okay, since F2 the displacement is more, here the displacement is more, F2 is less, we apply less force, and F1 the force is more but the displacement is very less. Here the displacement will be very less, so we will get a huge amount of force. So it means conservation of energy. This is okay. I think so. So next thing is, this thing is a good thing, you can see, but okay. Suppose if this shown in any kind of problem means you will have a clear cut understanding. So most of the times we do usually see the problem things. So the next time we can just go upon, and you can see here guys, for example I'll just take this example and I'll examine it to you. So this is the thing. Let us assume this is a manometer. So here the pressure is P and here the density is rho. Here it's been filled up with the water, it means water of density, and here when you go downside, what will come? So here the entire thing is fully based upon filled upon mercury. So this is the entire thing, this is fully based upon mercury. So suppose see guys, here the density is water and here it is mercury. So when you now we are just drawing a straight line. So here what is that and here what is that? Here at point 1 the water is there, but here at point 2 the mercury is there. So P1 equal to P2 will take? No, definitely not. The density should be same in the both of the side sector. So what we will do, here we will just put an alignment. You can see here the bottom part is fully filled with the density of mercury. Here 3.3 point, and here you can see here the 4 point. So P3 equal to P4, because you can see guys, here it been fully filled up the density, and here is also fully filled up the density of mercury. So that's why the taking of each and every section is much more important. Suppose if you just placed here means here 6 also, it's been also equal, P5 equal to P6. So the simple thing, the left side and the right side, the density should be same. Okay, we can go to the next one, and this is okay, this one okay, this is other thing. Okay, let's go to the next one. See, mostly as the example or any kind of questions comes, I will just tell in that kind of thing, so that you will have a clear cut information. So guys, until now we are just seeing only hydrostatics, and next one is aerostatics. Dam. So you can see here guys, in this dam, See, in this dam, is the water behind the dam is continuously moving? No, definitely not. So the water remains in a static condition. So hydro means water, static means it is being in a fluid at rest. It means especially liquid at rest. Suppose aerostatic means the air is at rest. Aero, yes. So in this, it means you can see it means the entire air which is filled inside it remain in the stable static condition. Mostly it is not moving, though that's why it is called as aerostatic. So this kind of things, it means you can see this entire balloon it means the entire air is being filled inside. The air is not moving in a particular direction. So as we just about this is kind of thing, it's in the aerostatic. Air means aero means air, and static means the air is remain in the static condition. Okay, these are the two basic things you have to just remember. So the one of the next interesting thing, another thing we have to just look upon is this one. This is stagnation pressure. Stagnation pressure is so much simple, guys. You can see the stagnation pressure at a point in a fluid flow is the total pressure which would result in the fluid is brought to rest isentropically. So stagnation pressure is, what's the formula of stagnation? See guys, this is one of the most important formula. Stagnation pressure equal to static pressure plus of dynamic pressure. Dynamic pressure. So I'll just see an example. So stagnation. I think so. Here, basic thing is only is coming, but okay. See, now you can see whenever you see a fight, it means aircraft. You can see here, guys. Here the lines are moving. Here continuously lines are moving, but here you can see like this it's been moving. But at this particular location, the pressure will be so much higher. So pressure won't change at all. Pressure won't do anything. So pressure will remain constant. Okay. So here you can see the pressure will be so much. It means tremendously so much high. But here you can, for example, here the pressure is about 10 means here 9. Here also continuous changes depending on the airflow. 9864 here 9864 like that it will change. So pressure, when the pressure comes under a constant value, it means at the rest value. You can see bought at isentropically. Okay, isentropically, as the video is going, I'll just tell what is the meaning of isotropical also. So stagnation pressure, what is the formula? Static pressure plus of dynamic pressure. So static pressure is generally P atmospheric pressure, 1.0132 bar. It's a normal pressure. Okay, dynamic pressure means moving of fluids. So as the fluids is moving around here, the pressure will little bit increase. Plus of this dynamic pressure, it means the velocity, it means the kinetic energy is centrally converted to the pressure energy. So okay, see guys, this you don't confuse. I'll just, as the video going on, I'll just explain in enough other chapters. So of the both of the things called as static pressure. Okay, the next thing we can just go here. Next one is a pressure head of liquid. So mostly in this you can see, in this I just told in the before example. In this mostly what you will do, we will also pressure head HED. So as I just mentioned about pressure equal to rho G into H. So what you are just doing is, we are just combining of this rho and G into specific weight of the fluid. It means specific weight equal to W equal to rho into G. So specific weight equal to, so pressure equal to rho into H. So what is the value of H? H equal to, this is a pressure head, pressure divided by specific weight of the liquid, of that particular liquid. Okay, specific weight equal to density into gravity. Okay, now you can just go to the next one. So we'll have a clear cut understanding. So you can see the first question. What is given? The pressure at a point in a water column is, the pressure is given. What is the corresponding height? So what they are asking, what is the height? So pressure equal to 3.924 Newton per centimeter square. So what is the height? Pressure equal to what? Density, gravity into height. So what they are asking, height equal to pressure divided by density into gravity. So pressure 3.924 Newton per centimeter square. Okay, meter square you have to just convert. So 10 power minus 2 the whole square, which is given in centimeter square. Okay, now it's been converted in the meter square. Divided by density, what is that? It means water is given into 9.81. So okay, now you just make a multiply and do all of the things and you will get the required answer. So next thing is, you can see the second thing is the Pascal. It means 3 centimeter column of meter. It means what is they are asking the pressure equal to rho G H. So height is given, height equal to how much? 3 centimeter column. So you can see 3 centimeter column. So for example, you can see in this, like this H is given. H is how much? You just consider this is given. So what is the height? It means what is the pressure at the bottom. Okay, it means for example, this has been located here. The height is given 3 centimeter. 3 centimeter. So here they are asking the pressure P equal to how much. So we will just calculate this P equal to rho g h. So they are asking for mercury. Mercury for density is equal 3600 kg per meter cube. Okay. So we just pressure equal to 3600 into 9.81 into 3 centimeter. 3 into 10 power minus 2 meter. Okay. Now we just make a multiply and you will get the required answer. So next one you can just go over this one. So what they are asking at the depth, it means at what depth, it means they are directly asking height equal to how much. So density is been given and will the pressure be equal to 1 bar. So pressure is 1 bar. So 1 bar always just convert into Pascal. So pressure equal to rho g h. So 1 bar 1 into 10 power 5 Pascal. Pascal means Newton per meter square equal to density what to know, since it's been given as a oil. Okay, oil of density 784 kg per meter cube into gravity 9.81 into height. Okay, from this you can calculate the height. Okay, we can go to the next question. Okay, this is a conversion of a column of height of one liquid into another. Okay, this is a good thing, right? We can just go to this one. Suppose if this problem, if I just explain means, we can directly go to the next thing. So the next thing can come on. See, in the differential manometer, the height of fluid. When you want to balance the height of fluid, must versus the ratio of specific gravity. Okay, we can just directly go to the basic of explanation. Then I will just explain you this one. See, now we can just this is a, okay, we can just go to the this is it's a basic thing. Here okay, white how you can see, okay, you can see this one. So a basic thing. Okay, this center you just take and here they what they are given, a differential manometer head height head it means head of 0.5 mm. It means this side. Okay, this is a basic thing, and this side one fluid has been there and it has been located at 0.5, and this side it's been given 0.3. okay, but both the pressure are equal. Here the pressure is equal to here the P1 equal to P2. So what is the formula? Rho g of H1 equal to rho g of H2. Okay, suppose this is what is this one. This is a specific height. This is also specific height of 1. This is specific height of 2. So okay, so next thing H1 equal to H2 equal to specific weight of 2 equal to specific weight of 1. So but what in the question is asking, they are asking the ratio of specific weight of A and 2 is to be. So W1 W by W2 equal to H2 by H1. So what is the value of H2? 0.3. I think there will be 0.5. So what will come? 3 divided by 5, and 305 point means 6. So 0.6. Okay, 0.6 is the answer. So what is the value? B option is the value. So the same thing goes for this also. Okay, now we can go for this one. This is one of the most interesting thing that has been asked in the GATE 2021. Okay, here you can see here you can see guys, the pressure measuring device fit on the surface of the submarine. So this is a submarine, and here the pressure measuring device is been. So height is given h. So the absolute pressure PA is given absolute pressure 4.2 megapascal. So absolute pressure equal to gauge pressure plus of P atmospheric pressure. So this is gauge pressure, this is atmospheric pressure. So this is combination of the both. They are the density of the sea water density. Okay, atmospheric pressure is P ATM equal to 101. This is okay, and the depth it means h what is height. So for each and everything we have to just what PG we have to just take PG equal to rho g half h. Okay, now we just make a calculation. So what is the value of PG? PG means P absolute minus of P of ATM equal to, this is the gauge pressure, rho g half h. So 4.2 into 10 power 3 kilopascal, and what is this? Minus 101 kilopascal into 10 power 3 pascal. Okay, this one will not come. So kilopascal is kilopascal equal to density 1050 into 9.81 into half h. What is the value of it? Just make a calculation, quick calculation. Let's calculate it. This one is 4200. Okay, minus of 101. Okay, 4099 kilopascal divided by 1050 into 9.82. So what is the height equal to 0.3974. This is kilopascal, this is kg per meter cube, and this is meter. See, it's been given as a kilo, so we need only pascal, so into 10.3. We just make wait. I think so we are doing something in a wrong way. Oh, sorry guys, we did in a good way, it means right way, but this is the answer. And see, this is a kilo when we need a pascal, this is Newton per meter square. So height equal to 397 meter. So you can see, so this is the meter. So I thought a little bit we are just going wrong way, but this is the correct thing. Okay, I think so you got the point and you understood. So the next thing is we can directly go for the, it means a theory, little bit of theory, so you can have practical and good understanding. This one we will just come to the next thing, and then okay, this one, those things are super. And you can see guys, this is one of the most interesting that you want to just read it down. You can see, suppose in the interview also if they ask any kind of question like this, means you should be so much clear. So this is the thing. So here area, see this is area, all the A1, A2, A3, A1 equal to A2 equal to A3, so all the areas are so same. So the pressure is pressure equal to rho GH. So pressure is independent of area, so pressure in this, it means for the fluid mechanics, fluid at rest, the pressure doesn't depend on the area. Okay, you should be clear here, the pressure doesn't depend on the area. So the height, so h is same. So for this fall of the thing, the what will be the pressure? 1, 2, 3. The pressure P1 equal to P2 equal to P3. So the pressure will be completely same. Okay, you are getting the point. But guys, you must be very much clear. Since the pressure is same, it also doesn't mean the force also we need to see. Okay, see, suppose in this you can see the volume is here, it means this is V, this 1, 2, this is 3. Here volume of 1, it means volume 2, volume 2 greater, it means volume, okay, this one. Okay, you are getting the point. Suppose if the area, I am just telling, if the area is same and the pressure is, it means, I think so this concept you just understood, but it means the upper area also we need to consider. Okay, sometimes the people may ask, okay, what is the value of weight? Because the weight may also change also, as little bit the weight may also change, because the volume consists in the 2 is so much high, so weight of 2 is greater than, so weight of 1 greater than weight of 2. Okay, so okay, I think so you are getting the point in a very much clear and understandable way. But the other thing, where is it? This one I just wanted to tell to you. So why this kind of thing is been occurring, you can see here, right? This is the main thing that I just wanted to explain to you. So why, suppose, okay guys, in this you can also see the weight, it means the pressure. Since the pressure and as well as the area are also same, and for force equal to, it means pressure equal to force per area. So force equal to pressure into area. So how the force, it means pressure, this force is represent pressure force. Okay, not a normal force. We have to just give a certain kind of it means thrown to him, because he is being a fluid mechanics, so pressure force must be given. So you can see here, it means the entire fluid is being filled over, the entire fluid is being filled over here. So as this consists of, it means as the V, it means for this you can see we are just applying any kind of force, so opposite reaction of force must be there. So like this, so both two type of vertical force must be there. So okay, like this. So that's why it's been here. So you can see the entire fluid, it means the entire weight of the fluid acts downward. This F reaction 2 in vertical output, so F2 and F reaction force V2. So this one, this thing and this thing you are just cancelling. So in this thing you can see the weight is acting along with the f of, it means vertical downward force. Okay, so that's why we need to consider each and everything. So you can see this W2 goes in a so much 12, and see for a force and weight is 10 means you can see here the volume is, since it is so much, you can see the weight will be also a little bit so much, so 12, but the reaction force acts also in the upward direction, so it is -2, so the force will be 10. So you can see in this the weight will be so much lesser, as I just told about in the weight, it means W3 is so much lesser, and here the weight is so much lesser, there the means vertical reaction force acts downwards, it increases the weight. So you can see this is there. So all the forces are equal because due to the equal and opposite reaction force, the force will be equal. Okay, the next thing is the pressure is independent of the shape of the container. Okay, shape, not the height of the container. The pressure is independent of the shape of the container, but it depends on the depth of the static incompressible fluid. This is called as hydrostatic paradox. Hydrostatic paradox. Okay. Next is, this is one of the most important things that you just want to look upon. Suppose if we just completed this one, you can just shift on to the next one. You can see this one. Wait, I'll just put a different liquid. So yes, there is no different liquid. Differential liquid, not different liquid. Okay, this one is a good thing. You can see here the liquid is other, here the bottom is liquid is other. You can see there are three type of liquid: liquid 1, liquid 2 and liquid 3. So by this is a kind of smaller basic explanation. See this each and everything. So the same kind of thing is being taken here. So you can see here guys, as I just told about this kind of thing, here the 1, here the 2, because bottom is same fluid and the bottom is same fluid. Okay, so in this you can see here the upper is a different fluid, so this kind of pressure will be same, pressure 1 and pressure 2. So rho g h1 equal to rho 2 g of h2. So g cancel, rho 1 of h1 equal to rho 2 of h2. So by this basic formula itself, you can just calculate what are the other kind of thing that's been going to occur in this. Okay, so next thing you can see this one. For this one you can see this, there are two containers, but the pressure P1 equal to P2, but difference of density. Here the water is there, here the entire thing is water, and here it is mercury. See, mercury, the volume of the mercury is so much lesser, but the volume of the water is so much higher, but the pressure is same. So P1 equal to P2. So what will, this is the same formula, it's rho 1 of h1 equal to rho 2 of h2. Suppose guys, in a best case scenario, if the height, it means if this is, if height of mercury is just 1 meter, height of mercury is 1 meter, means you just calculate it, the density of, it means height of the water. For mercury it's only, we just fill about a 1 meter of volume, means you can see density of water 1000 into height h1, it means height of the water, this one h1 equal to 13600 into h2 is 1 meter. So we just make a multiply, h1 equal to 13600 into 1 meter divided by 1000. So h1 equal to 13.6 meter. So for the same pressure, of each and everything, if we filled a mercury of only 1 meter of height, means for the same pressure and for the same everything, we need to fill for water literally how much, 13.6 meter. So height of mercury is only 1 meter, means height of water should be 13.6 meter. So can you just imagine, suppose if we filled in this manometer of any kind of fluid with water, means how much height we have to just, it means we have to just replicate in each and everything. So that's why we are just using the basic. So that's why we are using the basic, the mercury thing. So instead of, if you use water, means the manometer tube and the measuring thing will be so much length. You can see for water this goes around 13.6 meter, means the length of the tube will be so much higher. So that's why it is so much difficult to take the water as a measuring fluid. So that's why we are using the mercury as a measuring fluid. For the same pressure, water should have the height of 13.6 meter. Higher the density of fluid, lesser the depth of the fluid. Okay, higher density higher, the depth of the fluid will be lesser. So this is the basic formula. Okay, the mercury has higher density, hence requires lesser depth for a given pressure. So this is one of the main reasons why the mercury is used as the, it is in the manometer. Okay, so okay, we can just go to the next one. barometer. This is one of the most important thing that I just wanted to look up, and I also just wanted to, because in this directly they just ask one question. Literally one of the most interesting thing that you have to just notice on. Wait, I'll just display an image. See, this is the barometer. Okay, you can see clearly, guys. This is the entire thing of barometer. You can see here the until it is being by the mercury, and you can see as the pressure also rises, and after the second level here it becomes entirely vacuum. Here the pressure entirely will be in a negative, it means lesser than atmospheric pressure. Until here only the pressure will be in atmospheric way.